Hi everyone, I'm really excited today because I'm going to be building the new Nest Box System prototype for eggmobiles. And this is a project that's been sitting on my table for way too long. Actually, I started it last winter, and this is when I teamed up with Richard Perkins, who is one of the leading experts on small-scale regenerative agriculture, sort of like a spearhead of this movement. And he basically wanted to build an eggmobile that would be semi-automated. So in order to do that, we need to have nest boxes, rollaway nest boxes, that allow the collection of clean eggs. There's a conveyor belt where the operator comes at a certain pickup point and just winds all the eggs to one place, and he neatly organizes them into cartons. And so what's automated about this system that it has a mechanism for what's basically kicking out the chickens out of the nest boxes before going to sleep. So Richard first sent me a couple of his sketches, and based upon that I built my first model. Not built, but I just 3D designed it in CAD, and we discussed things. The first model had too many parts and it was not so easy to manufacture, so over the course of a couple of weeks we had the next design that was much simplified and pretty easy to manufacture. And so I went on ahead and I just built the first prototype, sent it to Sweden, and I was eagerly expecting to see what Richard would say.
Look what just showed up.
So the start of the year was pretty chaotic at the Ridgedale farm because of the bird flu and because of the bad weather. And so finally at some point Richard installed the prototype into his eggmobiles, and what happened next was that chickens started to lay eggs all over the place, and it was not working out for him. And so the whole experiment ended by Richard taking out the nest boxes that I built out of his eggmobiles, and he just went back to the system that he knew worked. So he installed the old nest boxes, the wooden ones that would work perfectly. And so I have to admit, it was a little bit of a down point for me, because I've invested a lot of work hours in designing the thing, building the thing, welding, buying the material, taking it to galvanizing station and everything. So I was a little bit disappointed to see that it doesn't work out for Richard. And that's when I just decided to put the project aside and to have some time. But then what happened next was that I kept getting emails, I kept getting questions about the Nest Box system. And I discovered that there's a big interest in this kind of technology. So a few months later, I started working on what would be third design of the Nest Box system. And this time I'm pretty confident that it will work out quite nicely. And so yesterday I got delivered a bunch of parts. So these are all the laser cut parts that are needed to build the system. Well, not all, but some of them. And it's really exciting when you keep looking at the CAD files, at the 3D model, and the drawings, and then you finally have something physical that you can touch and see. So most of today's work will be some welding and mostly assembling these parts together. The first step to assemble this whole thing together is to weld the frames that are the basis of the design. And I have what I have in front of me are these parts, and they are designed and cut in a way so that they snap fit together. So there's no guesswork here. I just put them on the welding table and weld everything together. On the first prototype that I've sent to Richard, I made these frames out of square tubes, or box section tubes if you will. And since there were multiple angles that had to be precise and a lot of holes, this time I decided to turn to laser cutting because it's going to be much faster than the previous method. And since laser cutting is a 2D process, I decided to add an operation of bending on a brake press so we can get a 3D profile with all the holes and other features precisely cut in place. Most of the companies that provide laser cutting will bend your parts on a press brake. So this was a quite smooth and successful process. And now that I have these frames welded up, I call them the bell frames, I need to hang them to mimic hanging from ceiling of an automobile. And I don't have enough space in my workshop, so I'm going to take this project outside. So first I have to make an improvised rig out of some wooden boards and a round metal tube that I already had lying around. And to stiffen the joints, I screwed in some flat stock to the wooden legs and welded them to the tube. And here I'm making a huge mistake of hanging these frames by some plastic zip ties that will provide some drama to this video further down the road. So stick around for some roller coaster rides. These long parts are going to be supporting the egg belt, the conveyor belt, and at the same time they will connect the bell frames together. So we're just attaching them with some nuts and bolts. Over at the 3D printing farm we have a little jig and some pulley parts coming up. So this is a little jig that I'm going to be using for aligning these parts together perfectly. So this is the main frame, sort of a chassis of the whole nest box system assembled together. And what we need to do now is to get that egg belt on. So first I'm going to be manufacturing some pulleys for the egg belt. I'm using 80mm round tubing. And these are the laser cut parts that are going to act as self-centering flanges for the edges of the pulleys. So I'm welding these two parts together. And they fit perfectly onto an edge of the pulley. So I designed these little slots that allow welding to the edge of the tube. So at this point I realized that I didn't order enough of those parts, so I'm turning to my homemade CNC plasma cutter for making them. It's a simple machine that I had built with my friend Michael a few years ago. It runs on an old Windows XP computer, and we've scavenged the motors and other parts from some old industrial printers, so I spent next to nothing to get it running. Now I have to do some adjustments to the G-code and we're ready to go. By the way, I call her Squeaky, pretty obvious why. And just as I finished to cut all the parts, I realized that I needed only 2 pulleys, not 4. So actually I don't need those parts. It's a typical mistake that happens when you have adult age ADHD. This is a little 3D printed jig that will help me make a threaded hole exactly in the center of this metal part. I'm using a 5mm drill for an M6 thread. It's time to make our custom-made pillow blocks for the bearings. And now I can start assembling the pulley mounts. So these parts are a combination of a 3D print and a laser cut bent sheet metal piece that will hold what I call belt supporters, and those will prevent the plastic conveyor belt from sagging. And here come the belt supporters. It's early in the morning and I want to get as much as possible done on this thing before it becomes too hot, because we're in the middle of one of the heat waves that we've been having this summer. So once the sun is out, it's not going to be possible to work on this at all, so I have to wait for the evening. I love to combine 3D printed parts with metal parts. I just think it's a combination that offers a lot of possibilities for various purposes. The egg belt itself is a 1.5mm polypropylene sheet. It's 300mm wide, and it got delivered here to the Green Tools headquarters from Netherlands. So now you can see the bottom belt supporters in action. They hold it in place quite well. So to connect the belt to itself, I'm using a pretty crude technique. I'm going to weave it with some polypropylene strips that I have for packaging broad forks and other stuff. I'd really like to find a better solution for this, but for now this is the simplest method, and it works. To tension the belt, we simply pull the pulley mounts that can move freely on the square tube parts, and to lock it in place we simply tighten the screw in the middle. And what I have to do next is to tighten the belt pulley to the shaft, and I realized I don't have the right wrench for it, so I just asked Squeaky to make one for me. So now that everything is nice and tight, we can try out the rolling action. So the next step is to build the tilting floors, and I'm using 40 by 40 millimeter welded wire mesh for that. So while you're watching me build these floors, here's a couple of really important things. Number one, huge thanks to Richard Perkins, who initiated this thing and financed the production of the first prototype. Without Richard, I wouldn't be doing any of this, so a big shout out to Richard. Number two, once the prototyping is finished, all of the plans will be open sourced and published on my website so that anyone will be able to download them and make their own nest boxes. And if you want to support my work, please check my Patreon page, there's a link in the video description. Number 3. I've teamed up with some really great UK people that have huge manufacturing capacities, but are also very enthusiastic about regenerative agriculture. So these nest boxes are going to be manufactured in UK, and we're hoping to bring them to market in a couple of months. You'll be able to hear a lot more about that collaboration because some really exciting things are about to happen. Number 4. Big shout out to Anita and Jasper from Denmark, who have kindly sent me these nest mats so I can complete this prototype. There are plans on collaborating with them too, so we'll keep you updated about that. Number 5. All the steel parts that you see here in the build are still raw, and that means they'll have some sort of protective coating. They're either going to be electroplated with zinc or powder coated, whatever will fit the purpose better. So back to the build, here you can see that I'm trying out different types of clips that will hold down the mats so they don't fall once the floors are tilted. And then we're adding on the thin sheet metal galvanized parts that are going to form the walls of the nest mats themselves. So as the sun started to set and it started to get darker, my building process had gotten darker as well because of what happened next. And what happened was that I made a really stupid decision of hanging the whole structure with some plastic zip ties. In my defense, those were some heavy-duty zip ties and I used multiple on every pivot point, but being out there in the sun the whole day, they failed and the whole thing collapsed and crashed on the floor. At that moment I just stopped all the filming and I was 100% sure that I will never complete this video and post it. But since I would really like to start documenting my work in this manner, I just said screw it and let the whole world see what I did in my very first YouTube video. So don't subscribe to this channel because what you will see is more failure and no quick reward for your brain, no dopamine hits and quick satisfaction, just hard work and the reality of the process. So to wrap this up, I used some ropes and prusik knots to be able to lift the nest boxes back up onto the rig. It suffered a bit of damage, but I managed to assemble it and then I had no more time for the final testing. So this is kind of a downer ending, but hey, now I have to make a sequel and get some eggs rolling on those nest mats and the egg belt. Thanks for watching and see you next time.